Hello world, this is Samir and I welcome you all on this episode of AI Society. And in this episode, I'll be talking about a very interesting topic, which is bitwise operations on figures. And this is the topic that is really important for anyone to understand, which is being into the computer vision field. So in this video, I'll be showing you how the bitwise operations work on the figures like ellipse or square, and how these operations like and or XOR, all these bitwise operation works on these figures. So let's start with the video. And if you are new here, you can go and subscribe to my YouTube channel first and then continue watching this video. I'll post about machine learning, artificial intelligence and Python programming content on this channel. So let's hop to the video. Before moving forward, I must tell you one thing, that I'm gonna tell you a very important fact and very important secret about the bitwise operation being used in computer vision if you don't know. So let's start with the video. So here we are using Google Colab as a notebook. You can also use Jupyter Notebook, but there is some difference between the code of this to be ran on Jupyter Notebook or on Google Colab. So I'll be telling you the difference. There is a very minor difference to run this program on Google Colab or on Jupyter Notebook. So let's start. So what we are doing here is we are importing the important libraries that we'll need, and this is the library, this is the patch that we are importing just in the case of Google Colab. If you're using Google Colab, then only you should write this line, and if you're using Jupyter Notebook, just delete this line and the code will work fine. So let's start with it. We have imported the OpenCV module, we have imported the NumPy module for the mathematical figures that we'll be making, and this is for something that we'll see in the future, of this video. So what we are doing is, first we'll make a square out of NumPy module, and we'll be using NumPy zeros for making the square, and then we'll see how this square actually looks. And we'll also be making one more figure, which is ellipse. We'll see how these both figures actually look. So let's run this cell. Okay, so if you're thinking that what this line does is basically it takes it calls the method called rectangle from OpenCV module and pass the dimensions, pass the color gradient and the channel, and then it basically shows the figure that you are making. If you're using Jupyter Notebook, as I said, delete this line and use dot here. Like this is the small difference between Google Colab and Jupyter Notebook, that in Jupyter Notebook we use cv2.imshow, and in Google Colab we use cv2_imshow, and to use cv2_imshow you have to import a patch called cv2_imshow using google.colab.patches. So what this does is basically it shows you the figure that you are making. It shows you the figure that you are making through the NumPy and the OpenCV module, and we have made these two figures, that is square and ellipse. So let's moving forward. In this cell we'll be applying the bitwise operations as we apply on Python programs, as we apply on numerical data. In the same way, we'll be applying the bitwise operation on the mathematical figures. So let's run this. I'll be explaining you the code, don't worry. So what it does is we take an variable called and there is a bitwise and inbuilt method in OpenCV module which takes figure as an input, and we passed both of the square and the ellipse here as an input, and we'll see what AND operation looks like when we apply AND operation between these two figures, that is applying the AND operation between the square and the ellipse. So what in the traditional way, what AND does is it takes out the if you apply the AND operation on the sets, what it does is it basically takes out the elements that are matching in both of the sets. So in the same way, it gives you the answer, it gives you the output where these two figures are matching. That is, if you put this figure on this, then only this part of the figure matches. So in the same way, this figure is made by AND operation. So what it does is, it takes out an input where both of the figures are getting intersected. So moving forward, we'll be seeing bitwise OR operation, where in bitwise OR operation what it does is, it takes both the input and shows you as an output as in combined. So it's like a union. So basically this is how it looks when square and ellipse are taken as an input and applying an OR operator on both of the mathematical figure. In the same way, we will be applying the bitwise XOR operation. So in the same way, this XOR operation looks like this. If you don't understand the bitwise operation, then I must recommend you to understand the bitwise operation, and I'll be linking in the description about how the bitwise operation works in Python. So you can go and watch that video, or you can search it on YouTube. You can watch anybody's video that you feel feasible about. So after applying the XOR operation, the figure looks like this. Where square and ellipse are taken as an input and applying the XOR operation in between. Now we'll apply the NOT operation. As we know, NOT operation is something different than other operations, right? So from the other operators of bitwise, NOT operator is somewhat different. What it does is, basically it inverts the image, it inverts everything that is being contained in the image to provide the output. So in the same way, it provides the output like this. Like, if you remember that we have this square, we have made this square, and we are taking square as an input in the bitwise NOT operation. So what it does, it inverts the square. So this is how bitwise operation works in OpenCV. So telling you that secret that I was talking about in the starting of the video, and that secret is, all the masking operation that is being performed in the computer vision application is done using bitwise operators. That is how we are able to detect the objects, we are able to mask the objects into the photograph or the video, or we can say that there is a very heavy bitwise operation involved in self-driving cars, where we are able to identify the passengers, identify the road signs and zebra crossing in the road. So bitwise operation is the thing that really helps us to mask the images, to mask the important objects, and this is how it is done. So let's stop with this video, and in the next video, make sure you subscribe to my YouTube channel, and make sure you watch the video that I'll be showing you in the end of the video. So go and watch it. Thank you so much. Follow me on Instagram, ask me any questions on Instagram, I'm very active on that. So let's end this. Thank you so much. We'll meet in the next video.